Welcome to a lesson with Dr. Powell. Let's look at the derivative of inverse cotangent of x. So the inverse cotangent is the inverse of cotangent restricted to the interval from 0 to pi, just like cosine has this as a restriction as well. Well, actually, technically speaking, we've kind of made this rounded because we're not going to include the endpoints. Okay, so we've kind of restricted that. All right, so the same way. So with that in mind, let's proceed. We're going to let's write this as y is equal to cotangent inverse of x. Take the cotangent of both sides. So, and the cotangent inverse will undo each other to just give x. Take a derivative with respect to y of x. And we've seen what this is. This is negative cosecant squared y. And so then taking that, we know that dy dx will be the reciprocal. Negative 1 over cosecant squared y. Then we look for an identity with cosecant. So we know that cosine squared y plus sine squared y is equal to 1. We can divide everything by sine squared to get a cosecant squared. So we divide everything by cosecant squared. Sine squared, sorry. Divide everything by sine squared, we end up getting cosecant squared y over here. We get 1. And then dividing by sine squared, so we get cotangent squared. Cotangent squared y. So we have this nice relationship. We can replace this with 1 plus cotangent squared. And that's great because cotangent of y is just x. So this is really x squared plus 1. So this just ends up becoming negative 1 over x squared plus 1. So the derivative of cotangent inverse is this. The derivative of tangent inverse is this. Notice they're just negatives of each other. Let's investigate why. So tangent looks like this, and cotangent looks like that. So it's the same, but they're just kind of like a horizontal reflection of each other. And if you switch your x's and y's to be considering the inverse functions, they'd be vertical reflections of each other, which just means making the slope of one versus the other negative or the opposite sign. So it should make sense. This is the derivative of the inverse cotangent, and this one is the derivative of the inverse tangent. Thanks for watching.